Welcome to Introduction to Lockpicking. I'd like to take this moment to issue a warning. This lock contains hardware, so Max, try to follow along. All right, so we'll be discussing how locks work, because in order to exploit them, you have to understand how they work. Attacks against the locks themselves, say you don't have a key, you're trying to pick the lock. And attacks against keys, because if you can steal someone's key or find out what the key is, then the lock's picked as well. And finally, we'll be talking about how to improve the security of locks. As a quick disclaimer, this talk's to inform on security, not to help you plan your next heist. Locks keep people honest, so, I mean, be honest. Don't pick locks you don't own. Don't help someone gain entry to a lock that they don't own. And if you pick locks, do you do so at your own discretion and risk? I do not condone any illegal actions. If you're here to learn how to pick locks for the purposes of committing a crime, please leave. I deny any responsibility for actions taken as a result of this talk, blah, 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 fine print. Hand wash only, tumble dry on low heat. So, why learn about lockpicking if we're not trying to steal cool stuff? Well, it's fun. Just fully honest, it's fun to pick locks. And when you learn how to pick locks, you quickly realize that pretty much all the locks you rely on in daily life are just absolutely terrible. So your security is in your hands. If you want to ensure the security of the things you lock up, you need to know how locks work and how they might be attacked. So, how do locks work? Here we have a pin tumbler lock. You can see the large circle is the housing. The small circle is the plug. The red pin is the key pin, which falls into the keyway and is what the key directly interacts with. Above that is the driver pin in blue, and the driver pins are pushed downward into the keyway by a spring. You then arrange multiple pins in this arrangement over the length of the key to create a pin tumbler lock. When the key is inserted, the key pin and driver pin line up with the shear line between the plug and housing, and the lock is allowed to open because there's nothing obstructing it from turning. Depending on the style of lock, you might have different mechanisms that actually do the retention. The lock mechanism is just what stops the actual opening mechanism from happening. So in this case, if you have, say, a deadbolt, you have the deadbolt, and then when the lock turns, it pushes the deadbolt to the side or pulls it back in front of whatever you're trying to stop from opening. Now, ideally, locks are perfect. They're machined perfectly. There are no problems with actual machining. You can see all of the pins are perfectly in alignment. And when you turn a lock that's been machined perfectly, in the ideal world, all of the pins bind at exactly the same time. The problem is, locks aren't ideal. You might be able to see some of the pins are now put. Yes, Nathan?
What does it mean for pins to bind?
So when the plug turns inside the housing, the pins get caught at the shear line. And so if you have a lock where the pins are slightly out of alignment, one of them will hit the side of the shear line before the other ones. You can see. And then you also have just bad machining where there's a ledge there and grimy pins that might get caught more easily. Does that answer the question? Or? I think so. Okay. So, picking a lock. Because we might have pins that are binding in front of before other pins and imprecisions in the machining of the lock, you can often get the driver pin to latch. Animation? You can get the driver pin to latch onto the plug as it rotates. And if you do this in succession, these animations are not having fun today. If you do this for all of the pins in the lock, then you ultimately pick the lock. So you can see here, a tension wrench is inserted in the lock, putting tension on the plug. And then a pick comes in the gap above the tension wrench and feels through all of the pins until it finds a pin that binds and latches onto the edge of the plug. And when all of the pins are picked, the lock opens. There are a couple problems with this method. It's mostly that picking a lock takes some skill and finesse. And so ultimately, most of the problems with this method called single pin picking is that when you're new to lockpicking, you just pull down on the tension wrench way too hard. And so certain things can happen, such as overlifting, where the key pin gets pushed past the shear line and acts like the driver pin in stopping the lock from turning. Or you might bind multiple pins at once and get absolutely no feedback on what pins you picked or have any movement in them whatsoever. The good news is, because most locks suck, including this presentation. Back.
PowerPoint has a bug where if you open it for racing.
This is Google Slides.
Oh, okay.
Anyway, the good news is a lot of locks suck. And what this allows you to do is have absolutely no finesse whatsoever. So in this case, we're going to do the same thing as with single pin picking, except we're going to use a different kind of pick called a rake. And ultimately what we're going to do is apply tension to the lock and then just wang jangle all the pins around until they all happen to pick. And so we can demo that with this practice lock right here. You can see the side of the lock has been cut away, so you can see the pins inside it. You won't be able to see them from where you're sitting because it's small and I'm holding it. But just to start with, I can show you, if you insert the torsion wrench into the lock and wang jangle the pins around, the lock opens. Now, I'd like to invite a volunteer up who's preferably never picked a lock before to try picking a lock. You? You can come up too if you want.
You have locks in the lab.
Yeah, so what you're going to do is turn to face the audience, and you're going to insert the torsion wrench into the bottom of the keyway, and then push that way on it.
This way, right?
Yeah, and typically you can reach with those fingers there.
Right.
Yeah,
And then-
you're going to take the rake and insert it into the top of the lock.
This way or this way?
Either way you want, you just have to push it around. And try to manipulate the pins. You don't have to push up too hard, you just have to push them around. And you can see you've overlifted there.
Oh.
So release tension on the, there you go.
Nate, is torsion a real word?
I believe so.
I thought it was. Is it tension or it's torque wrench? So it's actually called a tension.
Mech engineer, is torsion a word?
Torsion is a word.
Cool. Thank you, Jay.
Got it.
There you go.
I got it.
Yeah, it's okay.
It's important to note that these locks are pretty.
Yeah, these locks are incredibly easy to open. However, so there you go. So you're gonna hold the lock and push down with your fingers. There you go. Then insert.
If you're learning how to lockpick, cutaways are
did
really nice.
Yep, there you go.
You can see whether or not you
Oh, it
overlifted
clicked, but it doesn't.
Oh, keep turning. You let it fall back. So try it again.
Rookie mistake.
Well, I mean, that's the point. A rookie mistake, but you still open the lock within like 30 seconds. You have to keep turning.
Oh, I did it again. Can't tell if that last one is that out.
That last one isn't a pin. You are pushing them all past the shear line, though.
Oh, I see now. It's still bad. Good there. Too far.
Pull the rake out. Oh, that's
Oh, that's not the rake.
no.
I see.
Does anyone have any
Oh,
questions
yeah, I
about-
did it this time.
There you go.
Yes.
Ladies and gentlemen. So as you can see, a particularly bad lock is particularly easy to pick, even if you've never picked a lock before. So raking isn't the only way to have a lock essentially pick itself, though. You can also use what's called a bump key. So a bump key is where you take a key blank, and file down all of the teeth until they're all at their lowest point, but leave a bit of material in between the teeth of the key. And as you insert the key into the lock, the teeth bump the pins up, and hopefully you bump them with enough force that the driver pins go past the shear line and then seat at the plug, opening the lock. Bump keys typically have some amount of rubber or other springy object in between the key and the lock, so you can repeatedly tap the key and try to get the pins to seat. However, that's not the only trick you can do with the key blank. Yep.
Is using a bump key easier than a tension wrench or a torsion wrench and a pick?
It can be easier, especially because it doesn't really require any, requires even less finesse than raking. You just put the bump key in, turn it, and then tap it a bunch, and then the lock opens. However, it does require more setup. You have to make a bump key and then use it and not attract any attention when you do so.
What are some of the downsides of using a bump key?
They're fixed to a certain lock system. So the only lock a bump key will work in is a lock that key is designed to fit in. Whereas picks, by just being little bits of metal that happen to push on the right parts of a lock, are more universal. So anyway, the other trick you can do with a key blank is called key impressioning. And that's where you have the lock leak information about what kind of key the lock wants. And so when you impression a key, you insert the key blank into the lock and then alternatingly turn the key left and right to find a binder. And when the pin binds, you jiggle the key up and down, and it creates small indentations on the key blank. This tells you where to remove material from the key, and ultimately allows you to create a key just by wiggling the key blank inside of the lock and removing material where you find divots. Lastly, also the lock might just have a bad retention system. For instance, commonly used in any lock that has a large gap in between the shackle and the lock body are shims, which you can buy or make from soda cans. And what you do is you insert them into the lock around the shackle and push away whatever's holding the shackle in place and just pull the shackle out and you've opened the lock. Of course, a lock might just have even easier ways to open it than using any particular tool. If I can find the mouse. I don't know if the volume's up. Might be too high.
I feel about finding new and innovative ways to get into our favorite lock maker, Masterlock. This is the new number 3. Here's what the bitting looks like. It doesn't matter with this technique what bitting you have, because basically you're not going to be fighting the lock. You're going to be getting in the lock using another technique. If this is on a chain or on a gate, you just apply a little tension on this lock. I'm just going to use my finger. I'm going to just hold it like that, and then we're going to take a brass hammer, screwdriver handle, or whatever, and you want to wrap it right here. Just give it a few knocks while applying tension, and you how easy is that?
Masterlock, ladies and gentlemen. So clearly, it's not just the key mechanism itself that you might be looking to exploit in a lock. It's also any number of other design choices that the lock maker has made. In this case, they made the shackle retention system movable. Pin tumbler locks aren't the only kind of lock you might be looking to attack. You also might be trying to get into a wafer lock, such as most automotive vehicles, like cars. Anyway, so you can see here, these are wafers, which act just like the pins in a pin tumbler lock, except the key goes inside the wafer instead of pushing up on the pin. You can see the red objects are the wafers, which are inside the yellow plug, which turns within the green housing. When you insert the key into the wafers move out of the way of the plug and allow the plug to turn within the housing. This allows you to take advantage of overlifting, whereas before we were stymied by it. and pick a lock by allowing the wafers to fall back into the plug after lifting them too far.
This is an overlifting attack. This is a very popular bike lock in Europe. So this is the key for the lock, fairly complex. It's a wafer lock, which means that this key actually moves through the pins. They're manipulated by instead of just running on the bottom pins, and it opens with a nice big chute. So what we have here is the blank for this lock. This is just a blank key, no cuts on it whatsoever. This is called an overlifting attack.
Importantly, the teeth are
Probably take a
higher
few tries.
on the blank.
So you put tension on it, put pressure on it, and then slowly just sort of jiggle it up and down as you pull it out of the lock. And as the wafers fall back to their natural positions, as the wafers fall back to their natural positions, they'll want to go into the positions that they're cut to for the key. Just like that.
Nice.
So we've talked about how to exploit locks and lock designs, but the other half of the puzzle is keys, and keys are certainly exploitable on their own. The first thing about keys is that we have standardized key systems. For any given lock, you know how many pins are in the lock, and you might be able to know what the exact pin heights are for all of the teeth on the key. For instance, here are 3 different key bitting systems, and you can see there's only between 6 and 10 different possible key, pin heights for each of the pins in the lock. In fact, and furthermore, key bitting systems aren't secret. They pretty much have to be public knowledge because everyone has to be able to have a key, but they're so public knowledge there's even an app for that. And so what problems we have are that the key space is easily enumerable. You can list pretty easily the number, all of the possible keys, at least easily compared to any key space standards we have for digital security. And that key space, in addition to being small, just 6 times 10 or whatever, well, 10 to the 6th. Anyway, math. It's limited even further by key bittings that might be secure. For example, any key that's just flat is not a key at all. It's just a piece of metal you shove into the lock and the lock opens. Kind of like a pick. And it's limited further by the fact that different key systems might have a maximum depth difference between any 2 pins. We still have a piece of metal we're shoving into other bits of metal. And so if you have, say, a maximum depth difference of 4 pin sizes, then if you have a depth of 5 between any 2 teeth on a key, the key just won't be able to go into the lock. And so it's not a lock at that point, it's just a useless hunk of metal. And so depending on the lock system, you get between 10 and 100,000 possible combinations, and some of those aren't even usable. And so if you want to explore what kind of key space you're looking for different locks, you can go to this website, which you can get to if you look at my slides after the talk. And this has the ability to calculate pretty easily what the key space looks like. So to limit the key space even further, is if you have a master keyed lock, like we have in several places here on campus. When you master key a lock, you insert a 3rd pin in between the key and driver pins, allowing multiple pin values to unlock that, unlock multiple pin heights to unlock that pin of the lock. So for every wafer you add to a lock, you double the number of keys that can open it, double the number of states that pin can be in when you try to pick it. It just inherently makes the lock more insecure. And it would be bad enough if the keys themselves just belonged to a relatively small key space, but we have to give these keys to people, and people really suck at security. For example, TSA. So the Washington Post published an expose on behind-the-scenes operations of the TSA. And in doing their reporting, they took a picture of master keys for TSA-approved luggage locks. And then when they published that expose, they accidentally published that picture of the master locks. And lo and behold, someone took this picture, 3D modeled the keys in it, uploaded those 3D models to GitHub, and people 3D printed their TSA Masterlock keys. TSA. We also have, where's the mouse? This guy, Pete Donahue, reporter for the New York Daily News, who, when investigating black market keys to get that allowed the possessor of the key to unlock gates onto New York subway station platforms and circumvent the turnstiles, then took a picture of himself holding up the key and published that in the New York Daily News. And in fact, that picture is still available on the New York Daily News website. Presumably the lock's been changed at this point, but he uploaded a picture of a key that let people onto New York subway platforms. So things you personally should not do with keys. Take and distribute pictures of them, especially if they belong to you. Carry them visibly, such as on a keychain, or on your backpack, or leave them out on a table, or let anyone handle them for any amount of time, seriously. Demo. I want everyone to take out a key. Wait, why are you? No, okay, take out a key. I just told you. Take a key, and just for a second or two, press it into the fleshy bit of your forearm, and then look at your arm. You've just copied your key. And it'll stay there for as long as you're dehydrated. All someone has to do is have access to your key for as long as it takes to press it into their arm. Then they can just put the key back, walk away, and take a picture of their arm, and they can carve a key to the exact key bitting of your key. And then drink water. Oh no, it's not going away. No one look at my arm. So, what can we do to improve the security of our locks? Well, the first thing is pay more money to have better machining tolerances. And now, obviously, this is usually something to do that's better, but you also have to weigh the cost of the lock against the cost of whatever you're trying to protect. If you're locking up your gym clothes, it clearly doesn't make sense to spend $200 on a good lock. You can also have special types of pins, like spools and serrated pins and even fancier things. So here are different kinds of pins you might find in a lock. These go in place of the driver pin. So you can see a regular pin is on the left and right. And then in the middle is serrated pins and pins with multiple spools on them, or a spool, and I don't even know what the third to the right one is. And so what this does is make it harder to pick the lock, because as the spool gets caught on the edge of the housing, you have to remove tension from the plug in order to get it past the shear line. Now, fancy pins aren't unpickable, but they require significantly more time and especially significantly more skill in order to pick them. And so fancier locks, in addition to just being machined well, will also have these pins that add even more time to however long it takes to pick a lock. You can also have sidebars, where in this case, this is a Primus lock that has teeth on the top and on the side. And so the key, without making itself larger, can manipulate more pins within the lock. You can also have non-standard pin designs, like in the case of this dimple lock, where the pins are all located on the side of the key instead of the top. And this isn't necessarily any harder to pick than any given pin tumbler lock, but just by being different, it takes a bit of different skill in order to pick it, and specifically a different kind of pick. You can't just go up with a rake and open it. You need the right pick to open a dimple lock. So if you want to learn more, I highly recommend you look at TOOOL, the open organization of lockpickers. They publish a lot of information on lockpicking and lock security. For example, all of the yellow animations, which albeit didn't play very well on my Chromebook, came from TOOOL. I also highly recommend going to DEF CON's YouTube channels and watching the hours upon hours of talks on lockpicking and lock security and exploitation. I can vouch for their effectiveness because pretty much all of the information I've regurgitated to you today is straight from DEF CON talks. And lastly, YouTube has a number of lockpickers that publish a ton of videos. For example, the hammer video is published by bosnianbill, who has hundreds, if not 1,000 or 2 videos of picking various locks and reviewing lockpicking equipment and stuff like that. And that's my talk. Any questions? No. Awesome.
Do you remember, what was it? It was
Just give him a number.
Okay.
100.
We'll get $30
Overcharge.
Did I say both?
You're the head TA.
Cole's the head TA.
Why do we store money?
Are these iFixit tools?
You need to like give it a couple
Yes,
seconds.
they're iFixit girl. Okay. I could go slower. That's chill. Oh yeah, show them. Were you trying to advertise?
Yeah.
So quick. Thanks. All right.